pill is smaller than a golf ball. It's about 10.5 centimeters in circumference. Inside the pill's rubber casing is a sphere of cork. They pour latex adhesive over hundreds of pills loaded into a drum. Rollers spin the drum to evenly coat the pills with the adhesive. This adhesive never dries out completely, and the pills remain sticky to the touch. Next, they loop 4-ply wool around the pill. This machine spins the pill to wind the yarn around it. This winding substantially fattens the pill. It's the first time a camera has ever been allowed to record this proprietary machine, so we can't show you all of it. They wind a second layer of wool around the pills. This yarn is 3-ply, and it thickens the ball a little more. For a third winding, they use another 3-ply yarn, but it's a bit lighter. The various layers of yarn are what gives the baseball resilience, so it springs back into shape despite being hit repeatedly. For the final winding, they use a much thinner polywool blend, because its surface is smoother. This wound pill is called the center. They weigh it and measure its circumference, which should be 22.5 centimeters. They add adhesive to a spinning drum, then load the centers into it. As the centers tumble, they absorb the glue and the wound fibers adhere to each other. The centers air dry for 48 hours, but remain sticky. Using this hydraulic press, they punch out figure-8 shapes from leather, complete with holes around the periphery, allowing them to be stitched into baseball covers. But first, they stamp the date and lot number onto them. Then they wrap them in wet towels. The moisture will make the leather pliable enough to sew. They roll the water-based adhesive onto one side of the cutouts, which sticks to the moist leather. They press 2 cutouts to the center sticky surface. It's an exact fit. They clamp the leather-clad ball in a vise, and it's time to sew. Working with 2 needles, the sewer pulls thread through the ball center and up through the holes in the leather pieces to cross-stitch them together. He rubs wax on the thread to stiffen it, because if it slackens, it's more likely to tangle. When it comes to cross-stitching, these workers are in a league of their own. They make quick work of the 108 stitches in each ball. There are 350 sewers in this factory, and they produce 8,000 to 10,000 balls per day. That's a lot of home runs. The final stitch goes through the center of the baseball and out the other side. The sewer then pulls the stitches into a V configuration to give the ball a consistent look and feel. The balls now roll into a press that smooths down the seams. Smoother balls are harder to grip, and they make pitching a bit tougher for the pros. Finally, a 3-headed stamper gives it the trademark, league logo, and the commissioner's signature. With drying cycles, it takes a week to make a professional baseball. It will be whacked and slammed out of the playing field. But that's life in the big leagues.
I've got a really cool baseball myth. This one is all over the internet.
All right, let's hear it.
Well, the idea is if you keep your baseballs in a humidor, like the thing that you keep your cigars fresh with, that it makes it really hard to hit a home run with.
Yeah, I saw this one on our website, and according to the fans at one stadium in particular, once they started keeping their balls in a humidor, the number of home runs went down dramatically.
For years, the Colorado Rockies home ground in Denver had the highest home run rate in the majors. But since they started storing baseballs in a humidor, the run rate has dried up. Is there a link?
Well, to test this myth, I think first off, we're going to need to build a humidor and stick some baseballs in it.
You know what we should also do is dry out a set of baseballs so that way we have something to compare to.
So before we go to the park and start hitting balls around, I think what we should do is set up a small-scale experiment in our shop. We'll drop both the dry balls and the humid balls from the same height and see which bounces higher.
It's a good idea.
Grant's plan. A vacuum pump holds the balls at a certain height, then drops them one by one in front of a scale.
So one important thing about this myth is that we drop the balls exactly the same way every time. So we're going to be very careful about how we attach the ball to the cup, making sure to line up the stitching the exact same way. And that way we can remove some of the variables from this experiment.
So, we'll have our humidified and dry balls hanging from the ceiling, and then when we want to drop, there you go.
Out in the car park, the guys set up to get the drop on this baseball myth.
You're going to be dropping from a height of 125 inches. So it's like 10.5 feet.
They'll drop 10 balls. The first 5 have spent 2 weeks locked in an old fridge with a dehumidifier, which cut humidity to just 10%.
Some good bouncing.
Yeah. These are all about 110 centimeters.
Ball 5.
Thank you. There's no ball 5. Not in baseball, there's no ball 5. But on Mythbusters. Wow.
The high-speed camera shows the dry balls bounced an average height of 106 centimeters.
That's
All right.
pretty consistent.
Great. Let's move on to the humid balls.
The other 5 balls spent the same time in a makeshift humidor. Carrie put a block of waterlogged foam in a perforated plastic container and then put that and the balls in a cooler. As the water evaporated, vapor escaped through the holes,
Seal this up.
raising the humidity inside the cooler to a damp 90%.
Humid ball number 1. Feel that. Just from touching it, you can tell that it's softer.
Can this match scale the same dizzy heights as the dry balls?
Wow.
Wow.
All right.
After soaking up the atmosphere in Carrie's cooler, it seems the humid balls just can't bounce back. The average height of a humid ball bounce is 91 centimeters, as opposed to 106 centimeters for the dry balls. That's a difference of 14%.
Now, in your typical baseball scenario, with an outfield of, say, 425 feet, 14% is almost 60 feet, which is a difference between an out or a home run.
That was really amazing. I think it definitely warrants further investigation.
Yeah, I say we get out to the baseball field and start hitting these balls and see which ones go farther.
Well, I just don't think we'll be able to both pitch and hit consistently every time. And what we really need to do is isolate the variable of humidity.
You know what I'd also like to do? I'd like to introduce a control into this experiment. You know, a mid-range humidity that we can test against the 2 extremes.
All right, sounds good.
Now, Adam and Jamie have already got the batting machine and the pitching cannon tied up, trying to crack the case of the cork bat. So, Grant's gone one better and designed a robot that bats and pitches. Here's the deal. The robot will have 2 arms, one holding a bat, one holding a ball. A motor turns the arms, bat connects with ball, ball goes flying to the fence. It's going to be geared for raw power.
Is this our gear?
Yeah,
Dude, it looks like a saw blade. And it's out of here!
So I've got my motor. It's mounted to a beefy plate on the machine. It's wired up to the speed control. That goes to a safety switch, which has this key. And that goes to a bank of batteries. And I'm ready to fire it up for the first time.
The robot batter's wired up. Grant gives it the juice.
3, 2, 1.
The ball jolted free before contact. The bat smashed into the springs, really hitting a groove.
So we're going to ditch the springs and go with some foam, some kind of rigid blue foam.
When the bat comes through, it'll hit the ball and break the foam, not breaking the bat. Hopefully this will work.
In 3, 2, 1. Hey!
Good job.
The bat is still intact.
Looks like the Mad Batter's ready to be taken out to the ballpark.
Here we are in beautiful San Jose, and look at the crowd. Ladies and gentlemen, get ready, because you are about to witness dry balls versus humid balls. This is how we're going to do it. We're going to use our robot batting machine, and we are going to hit 30 dry balls and 30 humid balls. And whichever goes farther takes it all home.
It's wood all the way in the big league, but in this case, an aluminum bat might better cope with the rigors of the rig.
We've got 3 sets of balls. Humid balls at 90%, dry balls at 10%, finally a control group at about 50%. Now our baseball hitting robot is situated right on home plate. It's going to hit balls into the outfield. Tori and Carrie will be out there with different colored flags, one for each type of ball, and they'll mark the point where the ball first hits the ground.
In their small-scale test, the humid balls had 14% less bounce. Will that result be replicated in the real world? Now, the robot worked okay in the shop, but you guys know only too well how things go on this show. It's a brand new, intricate rig with high-speed moving parts. Seriously, what are the chances of it working first time?
Okay, first we have the control at 50% humidity with the aluminum bat. 3, 2, 1. Nice!
Well, I'll be. Far from striking out, the Mad Batter's striking those balls as clean as Babe Ruth himself.
One small step for man, one giant leap for mankind.
I'm really happy with the rig. So she.
The guys mix it up, sending a barrage of dry, normal, and humid balls soaring into the sky.
Nice! I love it!
Given the small scale result, my feeling is that these balls are going to go not as far as the dry balls. You know, since there's more moisture in the balls, they're heavier, they're not going to go as far. But we'll see.
This is where all the magic happens. This is the data. This is what the experiment is all about.
With no wind to affect the flight of the ball, test conditions are perfect. And already, Grant can see a pattern developing.
Yellow flags, which are the most humid balls, are closer to home plate. The control balls, which are pink, are a little bit further out. And out here in the outfield, the dry balls, which are the red flags, are the furthest out. Still too early to call, but this might be a trend.
That's good. They're starting to group together.
Like some medieval war machine, the rig keeps kissing leather till the ammo runs out.
And there's definitely a pool of yellow, pink, and red flags. That means that the humid balls didn't go as far. Then comes the control at 50% humidity, and the furthest with a 10% humidity, dry balls all the way at the outer edge.
And that totally agrees with our small scale tests.
Yeah, it's a spread of plus or minus 15 feet.
You know, I think there's some truth to this myth, because there's definitely a pattern where the dry balls were going farther than the humid balls.
It's funny how such a small thing can make such a huge difference on the game.
If there's so many variables in baseball, I think it would be hard to attribute a decrease in home runs to just humidity.
You know what's weird, though? Starting this season, Major League Baseball teams are keeping their balls in humidors.
Well, that settles it for me. This is definitely plausible.
Plausible.
Plausible.